Hello and welcome. My name is Sam Welsh and I'm an application engineer with MathWorks. Today we're going to be discussing engineering design and documentation with MATLAB. And before we get started, I want to show you where we're headed. This is a couple of deliverables we're going to be producing during today's demo. This first one was generated using a new and transformative approach to authoring MATLAB code. We call it Live Editor. You can see we have rich text. It's formatted nicely, very professional looking report. Has hyperlinks, numbered lists, bulleted lists. You can embed images. And then it has equations, proper format with code and whatever output is produced from the code as well. So it's a very involved report. And secondly, we're going to be producing this other kind of report. This one was generated using MATLAB Report Generator. Now, it's a bit different. You have a lot more control over the formatting. You can start with templates from PowerPoint or Word or other, and you can use that as a starting point to generate a report. In this case, it's a very generic report. It has automatic table of contents, and it has nice, very informative output for maybe perhaps higher level meetings, or perhaps a type of report that is high volume, perhaps something like design of experiments, or any type of workflow where you might quickly change something and need to generate a report quickly. So that's where we're headed today. Let's get started. So first we're going to talk a bit about the challenges of the digital age in this modern era and how quickly things are changing. Now, why, when we look at some of these challenges, why MATLAB is ideal for engineering design and documentation and how important and crucial that is. Lastly, we're going to look at the key takeaways from today's seminar. So Jeanette Wing, Corporate VP of Microsoft, says that computational thinking will be a fundamental skill by the middle of the 21st century, just like reading, writing, and arithmetic. Now this says something. It says that the way that we communicate, the way we think, will be very integrated with computations, with software. Now furthermore, I think we all know that the complexity of knowledge and the volume of knowledge in engineering and science is expanding dramatically. And a great deal, an exceedingly amount of this knowledge is stored in the form of software, in code. Now, in order to transfer that knowledge or learn from what other folks have done from documentation of code, it depends highly on the quality of code documenting and what avenue they have to provide other ancillary information with their code. And if that happens to be sparse, it's definitely going to lead to knowledge gaps, or I like to call discontinuities. And that could be between experience levels, between disciplines. The bottom line is, in a world changing very fast, knowledge grows collectively, but it does produce the risk for gaps. So the challenge is, how do we share and retain all of this knowledge in a world that's shifting dramatically towards this computational thinking, all the while maintaining current ops? Well, we need to change the way we do things. We need to update and optimize our approach to engineering design and documentation. And how? Well, today we're going to show you if you can integrate technical context with your code in an executable format by just turning your code into a formatted document for sharing, you're definitely on the right track. So to facilitate the conversation today and to demo this capability, we're going to be using the subject of modeling an aircraft wing load. Now, you don't need to be an aerospace engineer that specializes in structures or need to remember any of that from school. But It is something that you should definitely be able to follow. Keep it high level. We won't get down into the weeds. But just remember, as we're going through it, don't get lost in the details of this particular analysis. Rather, think about the bigger picture of the analysis and how it pertains to you in your world. So first, we're going to be looking at analytically estimating wing loads. We're going to be doing that symbolically, analytically, and then we're going to use those results and leverage them for numerical analysis using FEA to calculate the stress in the three-dimensional world. And finally, as we discussed, we're going to be documenting these in a report. So let's get started. And let's head on over to MATLAB. All right, so this is a MATLAB workspace. For those that may not be familiar with it, just a general rule of thumb, you have the main tabs up top, and then workflows typically go from left to right along the tool strip. So if you're not sure where to start, that would be a mindset I would take. And we're going to talk about all these other areas kind of as we go along. So imagine if you're working on developing a mathematical model and you've done some work. You've explored in the command window here. You've put in some commands. You wanted to, for the sake of this little portion of the demo, keep it simple. X is 1 to 100. And let's say, oh yeah, here, you've already done it previously. So let's bring this, all three of these here, and create live script. Now you can see you have a .mlx extension to the file. And if you notice, the gray background behind is showing that this is code. Now you can quick change it to text from a tool strip. And if you notice, this is a dynamic tool strip, as the Live Editor tab is now showing, because we're looking at a .mlx file. So let's create our first live script real quick. Let's give it a title. Normal text. We can do heading. Let's say we want to add some hyperlinks. No problem. Go insert. And you get links. You can insert images. And you have control over the look and feel. And all the while, as you put in all of this, and of course you can add equations. Let's go ahead and add the equation here. You can use LaTeX syntax, or I like to use the selections from up here. So let's just start typing, say y equals, and do square root of x. Okay. And save it. Or just call it untitled. And if you run it, now what you can do real fast, you show the power of sections. So you add section breaks anywhere in your Live Editor between code and text. And you see it highlights blue now for these sections. It's really handy to segment your code and segment your story. So you can run the section or run in advance. And now we can run in advance or in advance. You can see in this case, our output is over here to the right. You could also put it in line where it goes just below your code. So that's a real quick way how to get started with live scripts. Not scary, very easy to get rolling. All right, it's also important to show real quick, this is where the magic happens. One click a button, we're going to be able to export all the work we've done in the output to PDF. So let's get going on the actual analysis that we've been tasked with today. I want to open up another live script. This one's a bit more involved. And it looks probably awfully familiar based on the report that we saw at the beginning. So as we go through our live script, we're going to be stepping through section at a time, looking at the output. And for this portion, our goal is to produce the total load profile. So we're going to be doing this analytically using Symbolic Math Toolbox. Now, Symbolic Math Toolbox, it provides functions for performing math modeling using analytical workflows that complement MATLAB's numerical workflows. So you can do things like manipulate, solve equations, integration, differentiation, all kinds of different calculus operations. And one very important point to make is it supports units now. That's a newer feature. And so it is extremely helpful for engineers keeping their units in check. We're going to be looking at this piecewise. So we're going to first just look at the lift, and then we're going to look at the weight of the wing, and then the weight of the fuel. And then we're going to combine all these results for our total load profile, once again analytically, but then we're going to take this representation and convert it to a MATLAB function that we'll be able to use downstream. So you have best of both worlds. We're going to be able to see the insights of what's going on in the math very well, document it well, and extend that numerically as we move forward. So I'm going to run this one section at a time and use the Run in Advance feature. First section didn't have any code, so nothing's going to happen. But here in the second section, this is where we get into our defining symbolic variables L, Ka, and X. And then this is the syntax for defining units with this approach. And you have L and X in meters. Once you substitute, you get the equation. And notice the blue M is representing the units. So you get direct feedback immediately that your units are in check in this case. So we're going to move forward and integrate this equation along the wing, along X, 0 to L. And here's our result. We're going to continue going. Now, once again, don't get too bogged down in the details here, but you're going to see a common theme with all three sections. We're going to do the total weight, and eventually we're going to come down and we will have found our lift profile, Q of L. And notice the units, once again, units per meter. So this really helps you understand much more than what numerical can bring to you in some cases. Let's keep moving forward. So the next part, we're going to be looking from the weight of the wing. Very similar flow. We're going to solve for that profile and keep our units along. We're going to integrate along the wing and do some substitutions, rearranging. And ultimately, we're going to do the same thing. So this is what we have here for that profile. U of W. And we continue with the fuel. Now the fuel is a little bit different. Depends on how much fuel is in there. But this is the analytical expression for the load. Now, what's great is you can very easily just combine all three of these for the total. You got the lift, weight, fuel, and once you plug in the actual parameters, okay, and that's what this portion is doing here. Let's go ahead and run it. Make sure I run this part. And moving forward, we can finally substitute. simplify, calculate our total load, and now we can use fplot. So first of all, we're taking this piecewise approach, right? And we can plot this and all the information piecewise as well without actually generating numbers. So we can take a look at our results. So here we have a plot. And notice that when I clicked on the plot, this tool strip changed to have the figure tab. So I can come in here. I could take the figure out into a separate figure window, but I'm going to keep it in here. And I want to give it a title. So let's call this wing load profile. And let's do X length. X as length in meters. And we could do the same for Y if we would like. Now, right here, this window pops up and you can either copy it. It essentially is echoing what you just did through the interface. It's writing the code for you. So you can go ahead and update the code and it's going to stick it right there in your live script. Real convenient way to spruce things up with your figures, interactively make changes, and it's going to write the code for you and one step further, stick it right into your live script for you. Let's go ahead and save that and continue on. So the last step is we're going to use this MATLAB function call to save our results as a MATLAB function that we can call later on for the next part of the analysis. This is going to be our boundary condition essentially for the next portion. So this hopefully gave you a good sense of the types of things and the variety of tools for engineering design and documentation using LiveScript to generate a story, a narrative that's a lot more rich with information and technical communication in your world. I'm going to save that and run in advance. So now, one other nice thing with LiveScripts is when things aren't quite right, or it's going to give you warnings, it's going to give you checks to keep you in tune with what's going on. In this case, units are not supported once you go numerically, so it's just telling you, hey, I'm normalizing everything to 1, assuming your inputs are correct, your units are correct to this point, you're fine. But we're just letting you know that units are not going to be carried through into this function. So let's see what happened there. Now we have a function called total wing load that we can call to, for this wing, get that wing load. So let's go move on to the next portion. We're going to take those results, close this out. Oh, and of course, when it's time, export this to PDF and we have our report. So that's our first deliverable. And now let's extend this and move on to the next one. As a reminder, this report's a bit different, and we're going to be using MATLAB Report Generator to generate it from this next live script. So let's get into it. Close that one down. In this one, we're going to change it up a little bit. We'll do our lives, of course, still live script. We're going to do the output over here to the side instead of inline. So you can see two different approaches. So with this second analysis, we're going to be doing a static stress analysis of an aircraft wing. We're going to be using partial differential equations toolbox quite a bit in this live script. And here's the general approach we're going to be taking. We're going to import a CAD model of the wing in STL format. We're going to mesh the wing, do some unit conversions of the mesh, specify material properties, define boundary conditions, and then, of course, solve our model and visualize the results. And of course, after that, we're going to use MATLAB Report Generator to create our second deliverable. So let's get after it. I'm going to step through the section just like the last one. Here, we're going to define our model and import our wing.stl file, which is a CAD model of the wing. And next, we're going to visualize it. What we're showing here is we're leveraging some helper functions to get the right camera view. So when you're looking at 3D objects, it takes a little bit of tinkering, but once you do it and you get the right setting, don't close your figure window, hit File, Generate Code, and you can use all or some of that code that's automatically generated for you to have helper functions, so you don't have to tinker with it every time. This is just another example where automation from a MATLAB workflow is very, very handy, very efficient. All right, so let's take a look. Do we have a wing? Looks pretty good to me. So we got some immediate feedback. We know we're on the right track. Now let's mesh our model. Just need to specify some height and width parameters. And next, this model is in feet. We need to convert it to meters. So we're going to leverage the same units object that we did in the previous live script and create a simple scale factor, and then a few lines of code. We can convert our model to meters. So now we have our model meters that we'll be using for the remainder of this analysis. So we've already taken a look at that. And let's move on. Let's incorporate our material properties. In this case, we have aluminum alloy. We're specifying the Young modulus, Poisson ratio, and we can give a description. Notice the object-oriented notation. Excuse me. And the output here is in the form of a table. It's wonderful for output, perhaps in your Live Editor reports. But if you haven't used tables, they're very powerful for writing code. And as far as documenting things, you can reference your columns by its variable. So when you go back to read the code, you know what you're doing. Between that, merging, sorting, all the things that you can do with tables, I highly recommend you go check them out. Now we're going to do moving forward, the boundary conditions. We need to figure out what are the face labels that the model's identified. We have F1 across the wing, F2 is the tip, and F3 is constrained at the fuselage. So you'll see in this next chunk of code, we are constraining, we're constraining here. And we now need to look at the main boundary condition, which is the wing loading that we did in the previous analysis. All right. There we go. Next step, plotting the analytical pressure load. Now, we haven't solved our model yet, but this gives a good indicator, great visualization to show, hey, this is in line with the type of results we're expecting based on the stress of the wing. You can see here the color map maps to the pressure that is being felt on the wing. Now the next step, we're going to solve the model. Now during this portion, it has, it's done now, but it has done finite element analysis, a static analysis for solving all the stresses along the three-dimensional wing. So once we've got to that point, we can visualize the stress loads and deformation. And there's a couple different views we're going to look at. The first one, you can see displacement has a color map, and you can see, makes sense, being most displaced at the tip of the wing. And then we're going to next plot the von Mises stress. And that's going to be our last section. The next section is the function that we were leveraging before. So von Mises stress, when compared to our yield criteria, is extremely important. This is the portion of the analysis where, if you compare it to your material's yield stress, you'll meet the von Mises yield criterion. This is kind of like your peak breaking point, and you can see the maximum peak stress there at where it's fixed to the fuselage. So that's it. We have gone full circle. We've done our two analysis to, we've generated the report for one of them. We've not done for this one. Of course, we could always do this, export to PDF, but in this case, we don't want to provide all this information. It's a very defined report. We're going to use MATLAB Report Generator. So let's head over. I usually go to Apps, down arrow, and just start typing for the app that I'm looking for. You can always add it to your favorites if you use it a lot by pressing the star. Get there. And this is going to bring up the Report Explorer right here. So this is what you get when you first open with nothing. Now, we've already gone through the process of generating a report. You can use templates from, say, Word or PowerPoint to kick off the process. In this case, we're only starting from scratch. Okay. So let's open our .rpt, or report generator file, and let's take a look. So we have on the left are your different components of your report generator. And you can see here's all the ones that are available via the interface. Now, it's important to point out that all the functionality we'll show you today and all this functionality that's possible can all be done programmatically with the DOM API. But we're going to keep it to using the Report Explorer today to get you exposed to the kinds of things you can do with MATLAB Report Generator. So it's pretty straightforward. When you can bring these components into your report generator, and what you do on the right side, you'll have different inputs based on what component you've selected. In this case, title page. This is the title, subtitle, the image that we specified, the abstract, and all kinds of inputs here. We've identified chapters, and then once we go through that, we run the code using eval, the aircraft wing FEA. This is just like running it from the command prompt. This is MATLAB code. We're saying, hey, run this. And then what I want you to do is to give me all the information about the MATLAB version that I'm using. It'd be very important information to retain. It would be important for somebody to pick this up 5 years from now to have that info. It's really quickly one component put in there. And then the good stuff is we loop through each of the figures and include those with the tags for final report. So we can filter out the ones we want, filter out the ones that we don't need to include in our report. This is the type of control you can have with MATLAB Report Generator. When you're done, you simply can hit this lightning. Where's it go? File, report. Once it's generated, you are sitting pretty with your report. Now, sure, that's great. But the real power is when things change. Let's say right now we're going to try a different material, or perhaps we need to change some parameters. It's going to change all of our numbers downstream. If we didn't have this in our workflow, we would most definitely be copying and pasting and putting in new plots that represent the new data set. So there you have it. We have gone full circle. We've generated our 2 deliverables. We have the first one that was generated via directly from LiveScript and doing a save as PDF to generate this report. Then we have this report that we just generated with MATLAB Report Generator from also a LiveScript as well. One click of a button for each of them, and that's definitely how one can enhance engineering design and documentation. So let's finish out with a few more slides. The key takeaways from today is obviously with complexity and volume of scientific knowledge expanding, this can lead to issues, it can lead to gaps. It's tough to keep up with all the knowledge that's out there. And we need to adjust the way we document our engineering. As we enter this digital age, well, we're already in it as we enter it further. And MATLAB tools are ideal for enhancing this computational communication. And today we looked at Live Editor, Symbolic Math Toolbox, the PDE Toolbox, and MATLAB Report Generator as an example to show you how MATLAB can change the game. So generally speaking, Live Editor, once again, visually explore, analyze problems in a single interactive environment, turn your code into formatted, executable documents. Most importantly, that tell your story. You're able to put your engineering mind and your mindset and your story into your code. As you're working, you can generate results alongside the code, side by side or in line, incorporate images, hyperlinks, formatted text, equations, figures, tables, and it has the context-aware coding guides. Remember, we had the little warning there for us. It's real smart, keeps you in tune with what's going on there, and it gives you choices of how you want to handle them. And ultimately, this allows us to share with colleagues, retain our data, share with customers, share with the people in a crisp, clean, automated approach. Now, we also looked at Symbolic Math Toolbox, where we can interactively explore and rapidly develop math models and algorithms analytically. Things you can do is solve symbolic math equations like algebra, calculus, ODEs. Remember, we did the analytical plotting with fplot. Didn't even need to generate data, but we got our plots just like we needed. It supports units. I can't stress enough how crucial units are. I'm sure we all know from horror stories and not keeping track of them. And it happens automatically. And you can do SI or US custom units. There's a ton of units, so go check those out. And finally, you can extend this workflow by generating MATLAB functions. You can do Simulink function blocks, Simscape equations directly from your symbolic expressions. Now, that definitely tells a story when you combine that with Live Editor. We also looked at the PDE toolbox, and now this toolbox provides functions for solving structural mechanics. It can also do heat transfer and just general PDEs using FEA. You can import CAD, the LCL format, mesh, do your boundary conditions, specify properties, and you can solve in the static like we did today, or you could do time domain, frequency domain, and eigenvalue problems. It's ideal for visually exploring multiple parameters, and you could do design of experience with this type of workflow when you couple that with MATLAB Report Generator in Live Editor, of course. Then that allows you to really streamline the back end of your process, automatically generating rich formatted reports. And in this case, we did this. We did the reports interactively using a report explorer. You can also do it programmatically with a DOM API. And you can generate in PDF, you can do Word, PowerPoint, or HTML. And if you already have a template with your organization, you can start there and it can pick it up from your template and fill in the gaps. It's extremely powerful. So thank you for your time and your energy today. Let's just make sure as we move forward that we really think about how we're managing our knowledge. Knowledge is crucial, and retaining our code isn't good enough. So take a look at LiveScript, Live Editor, and the other tools we looked at today so you can enhance your pace of engineering and science. Thank you.